All right, we have the last word problem for this section. This one's a tough one. So we have two ATVs. ATVs are all-terrain vehicles. All-terrain vehicles are like a four-wheeler, they call them. Pretty fun things to ride on. So two ATVs are leaving a campground at right angles. At a right angle to each other. And continue in straight lines. ATV A travels 4 miles per hour faster than ATV B. After 3 hours of driving, the two ATVs are 60 miles apart. Determine the speed of each ATV. Okay, so let's make sense of this. Make sense of. So we have a campground, right? A camp. ATV A is going in one direction to a 90-degree angle of ATV B. There will be B, and A is going to be going faster, so A gets a little farther, right? ATV A gets farther than B. So they leave the campground at a 90-degree angle to each other. They go in straight lines. So A is going faster, 4 miles per hour faster, than B. So after 3 hours of driving, after 3 hours, this distance between them is going to be 60 miles. We want to find the speed of each. Find the speed of each. Okay, so this is a tough problem. So first of all, we want to declare our variables. Step 1, declare variables. So the variables are what we're looking for. What are we looking for? We're looking for the speed of each ATV. So I'm going to call RA the rate, or the speed, of ATV A, and R sub B, it's a sub B, it's below the R, it's going to be the rate, or the speed, of ATV B. So RA is going to be the speed of A, RB is going to be the speed of B. So we need to come up with some equations. That'll be our second big step, writing our equations. So the first big equation we have here, let's look at this. ATV A travels 4 miles per hour faster than ATV B. So the speed of A, so it's going to be equation 1. The speed of A, that's the rate of A, is 4 more than the speed of B. So B's speed is, you have to add 4 to that, right? Add 4 to B's speed to get A's speed, right? ATV A is 4 faster than ATV B. So the speed of A is the speed of B plus 4. That's the first big equation. Now a second equation that you can get out of this, if you call this here, this side here, the distance of A, the distance that A travels. Maybe use a different color here. What color should I use? Using an orange. That's the distance of A there. And this is the distance of B here. The distance of A, distance of B. There's a special relationship between these three sides. Remember the Pythagorean Theorem. This is going to be equation 2. The Pythagorean Theorem, it says that the distance of A squared plus the distance of B squared equals the hypotenuse squared. So the distance of A squared plus the distance of B squared equals 3,600. So that's something we have to know from the Pythagorean Theorem. The Pythagorean Theorem. There's some other equations here we can come up with. Some other equations we can come up with. Let's read a third sentence. the third sentence. So after 3 hours of driving, the two ATVs are 60 miles apart. Okay, we've already applied that. We've already applied the 60 distance here. We've already applied that. Okay, so we've already applied that. What else could we apply? We could use distance, rate, and time. Let's call this equation 3 and 4. Distance, rate, and time. So remember that distance equals rate times time. It's a famous formula. So the distance that A travels is the rate of A, or the speed of A, times the time. Now, how much time does A travel in? It travels in 3 hours. So you can replace this t here with a 3. So you can say that the distance of A is RA times 3. Or in other words, the distance of A is 3RA. And similar for B, you can do the same thing with B. You can say that the distance that B travels is 3RA, using the same, 3RB, using the same logic. Distance equals the rate times the time. The time here is 3 hours. Here you have equation 1 in blue. You have equation 2 in orange, and you have equations 3 and 4. 3 and 4. Distance equals rate times 3 hours time. Okay, so we want to put all these equations together. We want to solve this. So let's solve this. So I'm going to go solve. This will be step 3. So step 1 was declaring our variables, rates, RA and RB. Step 2 was writing these 4 equations. Step 3 is going to be to solve this. So the first thing I'm going to do, I'm going to take my master equation is going to be this orange equation here. Let me go back and look at my orange equation. I got dA squared, the distance of A squared, plus the distance of B squared equals 3,600. And in place of dA and dB, in place of this dA right here, in place of this dB right here, we can replace those with 3RA and 3RB respectively. So I'm going to put a 3RA in for the distance. That's going to get squared. I get this to work. There it goes. And for dB, the distance of B, I'm going to put 3RB. That's going to get squared. That's equal to 3,600. If we clean that up a little bit, if you square, first of all, the 3, you're going to get 3 squared is 9. So you're going to get 9RA squared plus, again, 3 here squared is going to be 9RB squared equals 3,600. Now, this equation has 2 variables. Eventually we want to make it so it has only 1 variable. But before we make it to only 1 variable, I want to simplify this. The numbers are getting awfully big. I'm noticing that here I have a 9, and a 3,600. These 3 numbers all have something in common called a 9, so we can divide both sides by 9. Divide both sides by 9 to make everything more manageable, less ugly. So doing that, the 9s will cancel here, the 9s will cancel here. We get RA squared plus RB squared equals, and if you do 3,600 divided by 9, you're going to get 400. That's just making things more manageable. Now, notice that we have 2 variables, RA squared, RB squared equals 400. So the 2 variables are RA and RB. Let's get this all in terms of 1 variable. If you go back, so we've already used the 2 purple equations earlier. We replaced dA with 3RA. We replaced dB with 3RB. We've used the orange equation already. The only one we haven't used is this blue equation right here. We're going to replace RA with RB plus 4. So right here, where I have RA, I'm going to replace that with RB plus 4. So I'm going to have RB plus 4. Replace that squared plus RB squared equals 400. So now I got this all in terms of one variable. So let's go ahead and simplify this out. What does it mean to square RB plus 4? That means I'm going to take RB plus 4 times RB plus 4. And then I'm going to have plus RB squared equals 400. Okay, I'll come up here and continue. Let's go ahead and FOIL a little bit. Let's do RB times RB squared. RB times 4 is 4RB. 4 times RB is positive 4RB. And 4 times 4 is 16. And all that's equal to, oh, well, not yet. We don't want to forget the plus RB squared, right? We still have a plus RB squared. Now this guy right here, we don't want to forget that, plus RB squared. That's equal to 400. So the next thing I want to do is combine like terms. I want to combine this RB squared with this RB squared. That's going to be 2RB squared. And then I want to combine my RBs. I got 4RB and 4RB is going to be 8RB. And then I'm going to have plus 16. That's all equal to 400. So notice what kind of equation we have. We have a quadratic. Remember, when you have a quadratic, you want to get 0 on one side and everything else on the opposite side. So we want to get rid of this 400 on the right side. We're going to subtract 400 from both sides. So I'm going to subtract 400 from both sides. I'm going to get here 2RB squared plus 8RB. And when I do the subtraction, 16 minus 400, what's 16 minus 400? That's 16 minus 400 is minus 384. I think so. 384 sounds right to me. Yeah. Then on the right-hand side, we got 400 minus 400, that's 0. Okay, so we have a quadratic equation. We have the quadratic polynomial on the left side, 0 on the right side. Let's make this a little simpler. Notice that 2, 8, and 384 all have something in common. They all have to have a 2 in common, so we can divide the left side by 2. If you divide the left side by 2, you have to divide the right side by 2. So let's see. 2 divided by 2 cancels out, and we'll have RB squared plus here 8 divided by 2 is 4RB. If you take 384 and divide it by 2, you're going to get 192. And then on the right side, 0 divided by 2 is 0. 0 divided by anything else is 0. So you have this quadratic equation that you need to solve. You can either use the quadratic formula or you could factor. I'm going to factor. I'm going to make 2 pairs of parentheses. This is going to be equal to 0. So first of all, you're going to have something times something to get RB squared. We're going to have RB times RB. And then you need to find 2 numbers that multiply to give minus 192 and add to give positive 4. If you think about that long enough, you'll come up with 2 numbers. You'll come up with, let's see, let me think about that for a second. Positive 16 and negative 12. Positive 16 and negative 12. If you multiply those, you get negative 192. If you add those, you get 4. So I'm going to put positive 16 here, negative 12 here. So then, since you have something times something equal to 0, your 0 product property says you set each factor equal to 0. So you get RB plus 16 equals 0, or RB minus 12 equals 0. So one of those has to be 0. Both of them don't have to be, but at least one of them would have to be 0. Okay, so continuing what I have. My first equation, I'm going to subtract 16 from both sides. In my second equation, I'm going to add 12 to both sides. So I'm going to get either RB, the speed of B is minus 16, or I'm going to get RB is going to be 12. Now one of these we can exclude immediately. We can say, okay, we're not going to have negative speed. You can talk about such things as negative velocities, but there's no such thing as negative speed, so you can't have negative speed, so we're going to exclude the first one. The second one we'll take, right? That's a positive, so we'll take that. So positive 12 miles per hour. So ATV B, its speed must be 12 miles per hour. Now, how do we find A given B? We go back to equation 1, and we know that RA is 4 plus RB, right? A was 4 faster than RB. So to find A here, we're going to take 12, which was B's speed, and add 4 to it. And we'll get RA is 16 miles per hour. And that's our solution. That's what we want to write. We want to find the speed of B and the speed of A. A lot of work.